Hello, geometers and seekers of truth. In this video, we are going to talk about similar triangles, but a special case of this with right triangles only. Okay, so in this picture below here, we have sort of the big triangle, which is ABC, right? So this is our big triangle. And then we take this line here from a vertex perpendicular to the other side. So this line, this special line right here, it has a special name. It's perpendicular to one of the side lengths and it goes through the other vertex. We call this the altitude or the height. And you may have learned about this previously in order to find the area of a triangle. But this is called the altitude or the height. And again, it's perpendicular to one of the side lengths and it goes through the other vertex. Okay. And so we have a 90-degree angle here. And what we're asked to do here is to list out all pairs of congruent angles and then explain our reasoning. Well, you have some 90-degree angles, so that's pretty straightforward, right? And then you have a linear pair here. So those angles there are also 90 degrees. So let's list this out. Angle CAB that's the big one, is congruent to angle CDA, and that's congruent to angle BDA. Okay. So all those angles there are 90-degree angles, so we can say with pretty good certainty that they are, with absolute certainty actually, that they are all congruent to each other. Now, beyond that, let's see what else we can say. Well, if you notice here that angle C and angle B add up to 90, so we can say a few things here. Angle C is congruent, they're not congruent, but they add up, they have a sum of 90 degrees. Okay. So the measure of angle C plus the measure of angle B is equal to 90 degrees. So this angle up here and this angle up here add up to 90 degrees. The reason that they add up to 90 is because they're acute angles in a big triangle. This angle C, angle CAB, and angle B add up to 180. You already got 90 degrees down here, so the remaining two angles must add up to 90 degrees. By that same reasoning, we can say that we can look at just this triangle right here. Let's see what makes more sense. Let's look at just this triangle right here, this green triangle, that angle C and angle CAD also add up to 90 degrees. Angle C plus the measure of angle CAD, that's this one down here, that adds up to 90 degrees as well. Okay, and when we put these two statements together, we'll prove them in the next video, but I just want to sketch out the reasoning here, that C plus B equals 90, C plus CAD equals 90, therefore B and CAD must be congruent to each other. So angle B and angle CAD must be congruent to each other. Okay? And we can follow that exact same line of reasoning to say that angle C up here and angle DAB have to add up to 90 degrees, have to be congruent as well. So think about this a little bit more and try to reason for yourself why this has to be true. I've sketched out some of the ideas right here that we have a bunch of complementary angles, and thus, because the angles are complementary to the same angle here, these two, angle B, angle CAD, are both complementary to angle C, then they must be equal to each other. And so we can update the picture as follows. Okay. Number two, we can list out pairs of similar triangles, and you can see here we have a couple pairs. So let's talk about these two smaller ones. So we can say that triangle CDA, okay, that's this green one right here, is similar to triangle A, D, B. Okay, so these two triangles right here, the small one and the medium, I guess, are similar to each other. We can also say that triangle CDA, that's the smaller one, is similar to the big triangle, and that would be triangle CAB. And then finally, we can say that this medium one here and the big one are similar. So that would be triangle ADB is similar to triangle CAD. CAB. Okay? So spend a little bit more time as well looking at these three statements. We have, in this picture, we basically have three triangles: a small one, that's the green one; the medium one, that's the one that's not shaded green, the brown one right here; and then the entire the big one, the combination of those two altogether. And we have three triangles, three sets of triangles here that are similar to each other. And from these similarity statements, we can use them to solve quite a few problems and also complete many, many proofs. In the next video, I'll prove rigorously why this is true, but this is a good way to start us off. As always, ask for help when you need it. Thank you for watching, and have a wonderful day.